Hello, everyone. I'm Priya Abiram, currently a high school senior and aspiring astronaut. And thank you guys for tuning in today to come hear the science experiment. We'll be having a lot of fun and happy belated International Women and Girls in STEM Day. So, without any further delay, let's get started and I'll switch over to my screen. Hope you guys enjoy. Alright, so today we're going to explore a really fun website called TinkerCAD and do a couple science experiments on it. And it is a really amazing platform that introduces you to many different aspects of science, from electricity to programming to computers to different devices. Has a lot of different tools that you can start learning through this show today and continue learning on through multiple resources that I can share toward the end. So it's an amazing platform and it looks something like this right here. So you have all these different parts where you could build circuits, you could make light bulbs light up, all done virtually on any device. And this device could be your computer, your phone, any device that you're viewing this show right now on. So you don't really need access to buying any specific materials, and the website is completely free to everyone. So I'm sure that all of you guys just need to be able to open up the link on the device that you're using currently, and you should be able to access a lot of different knowledge through this platform. So without any delay, let's get started with installing the software. So you could just go on to this link right here and create an account with your email account. If you are under certain age restrictions, you may have to use your parents' email account or any guardian's email account. So just have some sort of an adult supervisor help you out with this part if you need any help. And then you should be able to click circuits after signing in. So I have signed in to my account right here. And on the left, I see a lot of different stuff, like I said, that I could learn. You could learn to create your own 3D designs. And today we're going to be exploring circuits and electricity. So let's go ahead and click circuits and click create a new circuit. And before we delve into all the amazing things that TinkerCAD has in terms of creating a new circuit, let's learn a little bit about what makes circuits and a little bit about electricity, shall we? So these are all the different parts, right, that come together to make your basic circuit. So what is a circuit? I will, give you guys some time if there's anyone, take a minute to think about it. So a circuit is basically usually some sort of a power source, like a battery, that is creating a flow of different electrons, different tiny particles through wires, and that is able to do different types of work, like lighting up a light bulb or turning on different appliances like your refrigerator or your stove or the lights in your room. All of this is powered by electricity. And electricity is caused by the flow of very tiny particles inside these wires called electrons that are all moving, and that motion is able to help us do all these sorts of cool things that is able to help us live today. So we have different parts, and the first one is called an Arduino. Your Arduino is basically like this board. If you guys have heard of a motherboard, you can think of Arduino as kind of like a motherboard for a circuit, just like a motherboard is to the computer, you would consider Arduino to be for your circuit. So it is where you would put all your code in, you would do your computer and your programming, and you give the instructions for the circuit and tell it what to do, and the Arduino takes those instructions and sends it to the circuit for the circuit to be able to do the necessary things, right? And then here you have your wires, which are where this different electrons and tiny particles are moving around to produce electricity. Here we have a battery, which is our most common power source, right? We need some sort of a way to power our circuit up. We have LEDs, which are really small, fun, different colored lights, and they're all available in the simulation again. Of course, we have a button, right? Your button, you could think of like a switch. You would turn your switch up to turn something on and down for off, right? So when here in TinkerCAD, when you push the button down, your light bulb should light up, your circuit should work, and then when you turn your button off setting, then it would stop working. So we're going to explore different things that we could do with that button over there. And we have a resistor, right? So if our power source, our battery is very strong, it is giving too much power, sometimes what would happen is that these LEDs over here could burn out and they would have too much electricity flowing through them. So what we have is something called a resistor, which reduces the amount of power that is flowing through your current so that the different parts of your circuit, like your bulb and your LEDs, they don't explode because there's so much power going through the wires. So you want to make sure that, all these different appliances like your computer or your refrigerator, they have limits on how much current can pass through those wires. If you put too much current, then all these appliances may not work. So we want to use resistors to regulate, to control that flow of electricity. So now that you guys have a basic understanding of the parts that go into, creating a circuit and creating electricity, let's go ahead and see. We'll talk about a couple more that are specific to TinkerCAD. So we have the breadboard, which is a board that you could use to build your circuit, right? So it has all these rows of different holes that, you could connect wires in, and the rows underneath are, the board underneath is connected with each other. So you could put one wire here and then put it here, right? And then you could put another piece of wire here and put it down, and those two wires would be connected. So it's like a board where we could place all the different parts of our circuit, and it will automatically be connected together just by sticking it into the hole. So we'll see a little bit more of this practically be used on the TinkerCAD simulation. We talked about our wires and our battery, our button and LED. So we have the resistors that restricts the flow of electricity, and we also talked about the unit that is used to measure your resistance is called ohms. And if you guys see the resistors, right, they all have different colors. They're not just random colors that, someone picked out to put on. These colors have a meaning, and it shows how much current is the resistor going to resist, right? So we have like this little chart that you guys can learn how to read, and based on the colors of this chart, you would know how much current is the resistor trying to prevent the flow of current. So the bigger your number in your resistor, the more current it prevents from flowing. Of course, we have our circuit overall, and this circuit that you guys see to the right is going to be our first basic circuit that we're going to build on TinkerCAD, just so that you guys get a hang of the platform. And for those of you who are super excited to challenge yourself and take that a step further, we would have another more complex circuit coming up, which has an Arduino, so it would also take you into programming and coding. So before we go into that, let us go ahead and get started with building our first circuit on TinkerCAD, which is going to be a lot of fun. So let us go here, and if you guys see to the right over here, you have all these different components, right? And they are always adding new components to software a lot of time. So for this purpose of a simple circuit that we're going to make, we're going to search. You have a search bar right here. You could search any of the parts that you want. We're going to take out a coin cell battery like that. After we take out a battery, you could see that the battery itself has wires, right? All you need to do, delete that. So all you need to do is click on it once and then move it up and then click it again, and it stops right there. And then you could just continue flowing, right, making your battery wires flow. And then if you want to stop the wire, you would just double click right there, and it should stop guess it is not. Let's try that again. Let's try first taking all the parts out and then we can wire it together. So we have our battery. Next, what we need is a resistor. So we're going to go back here and type resistor, right? And we have a resistor right here, right? We're just going to place all the parts out. And then we're going to need an LED. Let's wait for it to load. There we go. LED. There we go. Now we're going to assemble our parts together. Just line it up, right? Take our resistor here. And we line that up just like that on the image. And now I think we should be able to connect our wires. So you would have to have your components out before connecting your wire. So click on one end, right? And then just drag it up and then click on the end of the resistor and boom. Now with this wire, you could also do a lot of fun stuff with this wire by clicking on this wire. You can change the color of it over here, right? And you have all these different colors, and we'll talk about what some of the common colors mean, right? So for example, red is usually used to signify positive, the positive side of a battery, right? So right here it says that's the positive side and that's the negative side. So the current coming out of the positive side would usually be red, like that. And then we go from the resistor to our LED, and then we can go from our battery and connect up to the other side, just like that. And now this side would be considered negative. So a circuit usually has a positive side and a negative side coming out of your battery, right? So now that we have this little circuit made, right, so we have your power source that's giving you electricity that is passing through a resistor, and it just looks like our image. So let's try clicking Start Simulation. And ta-da! Do you guys see that? That light bulb just light up. Just pay attention to the light bulb. Look at that. That light bulb turned off. Let's start again. Light bulb light up and off. So if you guys were able to make this successfully, congratulations. You have just made your own circuit experiment, but online. Right? So you don't need, the advantage of this is that, you know, if you don't have batteries or resistors or LEDs or breadboards at home, you don't really need any materials at home. All you need is this free website, and you can build all sorts of complex circuits and ideas and etc. So this is just, your basic amazing circuit that makes your LED light up and stop. And right now I'll be just pausing the video, and then the next one we will go into a more advanced circuit with computer science and programming for those of you guys who are interested and willing to challenge yourself. Alright, hello everyone. This is a continuation of the electrical and computer programming science experiment on TinkerCAD. So now we'll be learning a little more cool concepts in programming, right? So 4 basic concepts of programming that are the same regardless of what type of programming you do. There are different types of programming. There's C++, Java, Python, but the basic idea of what are variables, conditional statements, loops, syntax, pretty much are similar across the board. So let's go ahead and learn what these are. Variables, right? So as the name states, variables change, right? So unless you assign it a specific value, they can take on any value, right? So we have different types of variables. We have integers, which are whole numbers. We have char, which is characters, and then we have string, which is like a word or a phrase, right? So int stands for integer, right? And then the name of your integer is going to be pin, which is equal to 6. So every time you say the word pin, the computer is going to think that pin stands for 6, right? And the same applies for character. It would think that whatever that you assign it to is going to be one single character. And in string, it would think that whatever you assign it to is going to be a word or a phrase. We'll look into this a little more detail. And then we have loops, right? So what are loops? It's basically if you want your program to do a specific thing again and again, you can just put it inside a loop. And what it will do is that it's going to read that statement multiple times, how many ever times you tell it to read that set of program. So that way, if you want your light bulb to blink 5 times, then you can just put that into a loop and it'll just go through the program 5 times rather than you having to type it out each and every single time to make the light bulb blink those many times. So it's a cool function, right? We have that lets you do it again and again, run that set of code again and again multiple times without having to rewrite it. Now, conditional statements. It's like, hey, if this is the case, then do this. Else if this is the case, then do this. Else do that. So let's take a simple example, right? Oftentimes we want to go out and have fun, right? So if the weather is sunny, let's go play soccer. Else, if the weather is rainy, then stay home, right? So that's very basic, If the button is pushed down, then turn the light on. Else, if the button is up, then keep your light off. Or similar to a switch. If the switch is turned on, turn your device on. And if the switch is turned off, then turn your device off. Those are basic conditional statements. If this is the condition, then you would have to follow this. Else, if this is the other condition, you would have to follow that. So now that we have learned what, basically it takes, this is going to be the code that you guys are going to type into your TinkerCAD. So let's go back to TinkerCAD. And here is your space. We're first going to start off by getting everything we need for our circuit. So let's see. We're going to need a breadboard. Small breadboard should work. It comes out to be pretty good sized. Then we have a Arduino. Alright, we're going to put that right there. If at any time, everything's on top of each other and you need to turn it, you could just click on your device, click on your object that you want to turn, and then there's the little arrows here. So it's basically helps you, not that one actually. You click on it and then it's this one right here. And it helps you rotate like that. Now you have it straight up and down. Okay? And then we have, we have a couple resistors, LED, and a button. So I'm just going to put this on slideshow mode. It is really important that you guys follow the exact holes and the setup of this, because this is how the code is what the code relates to, right? So we are telling the Arduino to read off the wire at PWM port 6. So instead of 6, if you guys put this wire somewhere at 7, then your code or your circuit is not going to work because we are telling it to read off of 6 in our program. So it is important that you guys follow this layout exactly, or if you don't, you would have to edit your program accordingly to make sure the instructions are correct. So I'll just leave this on this presentation for a quick minute. You guys can feel free to pause the video right about now and try to just build this, and I'm going to be showing you guys now how exactly to build it. So let's see. We have wire coming from 6 out to 10 like that, right? So I'm just going to show you guys one quick example, and I'm going to build it real fast. There we go. 6 down, out. Let's give it a minute to load. all the way up to 12 right there. There we go. Should that be 12? Oh, no, it's actually 19i. Okay, so if we want to change the location, we would just click on the tip and we can change it anywhere we want, just like that. You just have to click on these different nodes, right? So we wanted it right there, okay? So now we go back and we continue building the rest of our circuit. So I'm going to do that real quick and you guys can take a look at the screen and try to build it yourself. Alright, so here it is. I basically just took this, right, and I rebuilt this following the same ports, the same wires. Just note that, the main difference between these are the colors of the wires. So this is where I also wanted to mention, right, the color of your wire is not going to affect how well your electrons are able to flow, or how strong your current is, or how well your electricity is able to flow. The color is just for your own way to distinguish what type of wire does what function. So it is honestly up to you to have fun with the colors of the wire and the different, the wire types of it, but just as long as you make sure it's all connected properly. So now that we have our entire Arduino and breadboard set up, we're going to take the code that is on this slide over here. I'm going to just present it like this, and you guys should be able to just type this exactly onto the Arduino code. Right? So when you go on TinkerCAD, when you have this on the top right corner, you have a button that says code. And you have different types, right? There's blocks plus text, and text. You want to click on text because we'll be coding with text, right? We're typing out our code. And if you guys see, this is the same code that is over there. So I'm just going to zoom in for you guys to be able to see, and you can take a minute to again pause and just type down all of your code onto your TinkerCAD code simulator, right? So once you type all of this exactly, and while you guys do that, I can go ahead and explain what's happening, right? So we are assigning integer LED 6, right? So LED equals 6. So because that's our first wire here is coming out of 6, so this is what's going into our LED, and then our button is going to be red out of 5. So whoops, let me just zoom back out, let it load. Let's try to move this over and zoom in a little, zoom out a little. There we go. I think that should be good. All right. So, and then we have another variable called button state, and this button state is the variable that will determine whether the button is pushed down or the button is pushed up. Okay, so we have these three variables and we're setting it up so that when the mode when the button is on, it is the LED's on. Button is pressed down, the LED's on, and the button is released, the LED's off, like that. We're setting that up. Now here we're making a loop so that we don't have to write the same code each time, every time we press the button and every time we release the button. Right? So we make a loop so that the program automatically knows that whenever the button is pressed, it comes to read this and learn from this. So the state of the button, we're going to ask a digital read is a function that tells the Arduino to, okay, go look at what state the button is. Is the button down or is the button up, right? Is the button pressed or is the button released, right? So if the button state is high, then LED is high. Else if the button state is low, LED is low. So here are our conditional statements that we talked about. If it is high, then LED is high. And else if it is low, LED is low, right? So high LED high and low LED low are just fancy way of saying on and off. So it's just fancy ways of saying that if the button is pressed down, the LED is on, and if the button's released, then it's off. It's just a fancy way to write that. So once you guys are done typing this out in your code box, right? So you could click right here, right next to code, see the button Start Simulation. When you click Start Simulation, you will no longer be able to edit your circuit. All you can do is to press the button. And ta-da, look at that. Observe your LED as I press the button. Boom, it turns on, and now it's off. It's on and off. Isn't that so cool, guys? You guys just programmed your own Arduino and electrical circuit to turn your LED button on and off. Should be super proud of yourself. So again, press it down, on, and off, right? So I hope you guys enjoyed learning this, and I just want to mention a couple things that if you guys, when you click Start Simulation, if you see anything red over here, then those are probably a couple error messages. Just go back and double check to make sure you typed in your code properly. Note that it is case sensitive, so it has to be the correct lowercase and uppercase letters. If my I here was capitalized, it's not going to work. If I have 2 spaces instead of 1, that may create an issue later, right? So just make sure everything is perfect and exactly like this. And if that's the case, then you shouldn't have any errors. And then over here, if this is correct and you don't have any red lines here, but it's still not working here, then just double check to make sure all your wires are in the correct place, right? And if it's not in the correct place, click Stop Simulation, double check, adjust the different positioning of your wires, click Start Simulation again, and boom, when you press it down, it's on. When you let it go, it's off, and the same applies. So I hope you guys really enjoyed that, and before finishing off, I just want to say that this was just the beginning of learning electricity, electrical engineering, and programming, and computer science, and seeing how all your different types of sciences come together to do the most simplest of tasks that we take for granted, right? And I hope that you guys take away by seeing this that just turning on one small LED light took up so much of science. Imagine how much science is around you in your day-to-day life. So hope you guys are inspired to continue learning and making new things and playing around with your hands. And this is a really cool platform because you have all these different tools. You don't need to buy any of it. You have it all for free in this software. You have all these different types of components. And when you go to TinkerCAD, you can also see some of their sample components that they have. Let's see, some of the other cool, really fun projects that you could make, like really big circuits that you can make. Once you get more advanced, you could obviously watch YouTube videos about just learning TinkerCAD, and once you get advanced, you can do really cool stuff like Christmas lights, and you could add sounds and music and noise to your circuit. Could do so much of really amazing stuff. So I hope you guys enjoyed this learning experience, and I could play this as a final thank you, and have a great rest of your day. Thank you for tuning in.